Good morning, guys. Just to start out for your homework check, make sure you send me the information that your parents or grandparents gave you about what food was like when they were growing up. Last week, we talked a lot about how food has changed since the 50s, and I want to know from their perspective what they saw. Now, for this week, we're going to talk about nutrigenomics. This is a fairly complex topic. We get into some pretty advanced biology. So if you need help on it, that's actually going to be part of the homework. Make sure you message me with questions. We're not going to go super deep into everything, but we're going to kind of glaze over it. So if you start to get confused and I start to lose you, definitely let me know. First, what's nutrigenomics? So nutrigenomics is a subset of epigenetics. Epigenetics is kind of a new field. It means control above your genes. So it's basically how everything around you affects your gene expression. So it's the air quality, stress, water, cleaners, and cosmetics, everything around you and everything in your environment, how it affects you. So it's kind of where nature and nurture meet instead of them competing against each other like we've made them do for years. We're putting them together and seeing how they combine for an effect instead of combating against each other. Now, nutrigenomics is just how food impacts your genes. So it's nutrition impacting on your genes. And we're going to focus on nutrigenomics partly because that's what our class is about, nutrition. Partly because that's the most well-researched subset of epigenetics. There's been a lot more work into nutrigenomics, especially in the last couple of years, than there have been in pretty much any other field. We're looking at the cleaners and cosmetics. That one's starting to come up to the forefront, like for the endocrine disruptors. Exercise is they're starting to look a little bit more at exercise. But they're still not as well researched as the nutrition portion of it. Now, why do we care? So partly because it sees how nature versus nurture, or nature and nurture combine to make us who we are. We are who we are as our DNA and the basic code for who we are. But our environment obviously has a huge impact on that. So what nutrigenomics sees how they work together to make you who you are, and what we can change about it. It's also a really good thing because not even that long ago, in the last 10, 20 years, we really thought that your genes were your genes. You were out of luck. If your parents passed something down to you, then you were probably going to get it. You were doomed. This is huge because this gives you control beyond just what your genes say. It doesn't mean that if your parents have high cholesterol that you also have to. It means that you may have to work a little bit differently and a little bit harder to control that, but it doesn't mean you're doomed. It means that your environment can have as big of an impact on your genes as just your basic DNA does, or as big of an impact on your life and your quality of life as your genes do. And that's very, very important because that's extremely enlightening for some people. And it gives them a little bit of hope because it's really hard to see, let's say your parents have a lot of chronic diseases. It's really hard to see them and then feel like you have no choices. I mean, you're not going to do any better than that anyway, so why try? This basically shows us, no, you have other options. It also shows us that food really matters when it comes to our lifestyles, and it shows us a little more insight as to why. Why what we eat makes such an impact, especially a lasting impact. Why our diets impact different people different ways. Why two people can have exactly the same diet and it will impact them differently. It also can make it so when we look at medicinal approaches and different diets, we can look at them a little more individualized. We've kind of done that in the past with trying to look at the body type diet or the blood type diet or all these different types of diets that are trying to be a little bit more individualized to us. What they're doing now is they're taking they'll go through people's genetic code and try to find the genes that stick out, the ones that we know certain foods have an impact on. And then you can fix the diet from there. So there are some people who are going to need, for example, more broccoli than others. There are some people who are going to need more garlic in their life than others. There are some people who shouldn't eat certain foods because they're going to have more of an impact on them than they would on somebody else. So really looking at those individualized approaches and seeing how we can make a bigger impact with our nutrition, because we can see how it's affecting our DNA. And that's also very helpful for a lot of people, because it feels like with a lot of diets, people will look at it saying, well, I don't know if it's going to work. This might not work for me. And it can get really frustrating to go through multiple diets over and over and over again, trying to figure out what's going to work best. This will give people the option to go through and try to figure out what's going to work on them based on their DNA. And they've done this for the last couple years. They've done a few basic studies with this. They looked at certain genes. We don't know a whole lot about nutrigenomics yet. We'll talk about that a little bit too. There's a lot we don't know and a lot that's still kind of a question mark. But there was at least one study a couple of years ago that really went into it. It picked out certain genes that were risk factors or that had a lot of control over things like osteoporosis or dyslipidemia or cholesterol that's too high in the bad places, too low in the good places, obesity, blood sugar control like diabetes. And they looked at people who were more at risk for those issues based on their genetic code, and they adjusted the diet to them. And it was actually really, really successful. And they did a great job. There were a couple of things as we learned a little bit more about nutrition, like we've talked about before. Nutrition is an ever-evolving field. So as we learn more, we'll be able to do a better job with these things. But it was more successful, and people were at least more likely to stay on these types of diet and be more successful with them than other types. And part of that's a mental thing. Part of that is just because those diets were made for them. And that's very hopeful for a lot of people. That makes them feel like it's going to work and it's going to do a better job because it was made for you. Why wouldn't it? So they're more likely to stick to it and stick to it for longer. Now, just to get into the basics, what are your genes? Your genes are just the basic physical and functional unit of heredity. It's your DNA. It's what makes you who you are biologically. It's what you get from your parents to make you the very basic of who you are. Now, when we're looking at genetic defects, those are issues that come up with your genes. There was some thought at some point that things like Alzheimer's were mostly caused by genetic defects, but only about 5% of the population on average has true genetic defects that affect them and cause sickness. Some of them they're not necessarily defects, they're just called SNPs, and they're just little changes in your DNA, but they're not true genetic defects that are causing a problem. So if only 5% of the population actually has a real problem with their DNA, that's a really good thing. That means we can make a difference with it, because if there's not a problem, then with just the DNA, you can't change your DNA, but you can change the expression of it, which is very helpful. So when we're looking at it when it comes to illness, your genes are basically your capacity to adapt to your environment. If we're thinking about it as a cup, your genes are the size of your cup. Everything that in your environment is trying to fill up that cup. Once it overflows, you get sick. So your genes are the size of the cup and your ability to empty it. Now, if you have a small cup or you don't have the ability to empty it well, then you're going to get sick more often. So your genes give you the biological advantages and disadvantages for your health, but your environment makes a huge impact on it, because if you're dumping more and more and more into your cup faster than you can get rid of it, it's obviously not going to do you any good. If you're in an environment that's just slowly filling your cup as you can empty it, that's great. It's going to more fit your lifestyle, and it's going to make you healthier in the long run. And when it comes to that, that's really just what sickness is. Sickness is the overflowing of that cup. It's you hit your capacity to be able to fight off any of these issues, your genetic and your capacity to basically fight off your environment. Things are bombarding you all the time, which makes you sick. Now, why does this matter with all of this? So when your environmental load surpasses your ability to adapt, you get sick. These are the basic, and just a couple of the basic sicknesses that you see when a lot of times with genetic issues, when people's environmental load surpasses their genetic ability to adapt to their environment. So they're filling up their cup and they're not giving themselves the opportunity to either empty it or have a big enough cup to deal with it. Things like allergies, asthma, autoimmune disease, cancers, chemical sensitivities, chronic disease, all of these are extremely common. And a lot of these are very similar to when we talked about the endocrine disruptors and the effects that endocrine disruptors had on the body. A lot of these are very, very similar. And we're going to talk about endocrine disruptors in just a little bit. Now, this is where we start to get into the fun nitty-gritty stuff, and you start to have questions. Now, how does gene expression change? So like we talked about, your DNA itself does not change. Your DNA is what it is. So you are predisposed through your DNA to get certain illnesses and be more susceptible to certain illnesses. But your genes can also turn on and off. So it's not the DNA that changes, it's the gene itself, and it's the gene changing shape. Now, it does this with epigenetic tags. Your epigenetic tags come from your environment. It's how your environment changes those genes. Now, we're just going to talk about DNA methylation and histone acetylation today, just because those are easy one and common ones. So methylation suppresses the expression of the gene, so it's going to turn it off. If you want to get into the really fun part of how it does it, you can with your homework. But all it does is it blocks the transcription factors from binding to the DNA, or it can recruit proteins that also block the methylated DNA. It basically has the same effect, it's just one more step. The histone acetylation activates the genes. So methylation suppresses, acetylation activates. And the histone acetylation just activates by making the DNA more accessible. It gets those transcription factors and opens everything up so that those transcription factors can reach the DNA. Transcription factors may also be another word to remember for your homework. When we talk, we're not going to go into too much about DNA and how it works and what it does. We're just going to talk about the effects. So remember those, and we'll go back on them again too. Now, how does this gene expression go wrong? There can be issues with methylation turning off genes that should be on. The example that I really like to use for this one are cancer-fighting genes. So the genes that tell a cell to, nah, it's okay, you're kind of sick, you can go ahead and die, it's your time. If those genes are turned off, then those cells will not die off. And that's part of the reason we get cancer. Those cells are not dying off. They're just becoming sick, and they're becoming a problem with the rest of your body because they're not dying off, and there are too many of those cells floating around not doing what they're supposed to because they're too old or they're not the right type of cell. So, and there are also genes that will come in or that tell something else to come kill off the cell. Those can also be turned off too. Now, acetylation can activate genes the wrong way, like with endocrine disruptors. I'm going to use cancer as an example with those too. If something acts like estrogen, it can, and it is activated too much or is activated the wrong way, it can put estrogen where it's not supposed to go, which can be a risk for things like breast cancer. And a lot of that will have to do with the endocrine disruptors that we talked about. a couple of weeks ago. Now, we are surrounded by all of these things that cause problems, like the flame retardants and the dioxin. Again, endocrine disruptors. They do cause issues. Your body is really good at taking care of those most of the time. But like we talked about, it's kind of like that cup. If you are putting too much into that cup all the time from your environment, it's not going to take care of things as well as it's supposed to. Now, free radicals can also cause damage and create problems with methylation. Now, free radicals are nasty little things that they're taking electrons from healthy cells to make themselves work. The problem with that is it just doesn't kill off the cell that it's taking the electron from. It basically makes that cell another free radical and another problem. Free radicals come from oxidation, and it's a basic byproduct of just us living, but normally we're really good at taking care of it. Now, free radical damage causes aging. If you cut open an apple and it starts to brown, that's free radical or oxidative damage. It's just aging. That's how we age. If we did not have any oxidative damage, we really probably wouldn't age at all. Our cells would be healthy forever. Free radicals basically make us age, and it's a big control system for our body. So they're not necessarily a good thing, but they are part of the control system. Kind of like when we look at inflammation, a lot of times we'll talk about inflammation being a bad thing, but it is a necessary part of our system. Free radicals are the same kind of idea. Now, there are foods that promote methylation that are very, very important. I'm going to give you some of these. Whoops, trying to skip over it. Now, remember, methylation does what? Suppresses the gene expression. So if you're looking for certain things to suppress the gene expression, and for a lot of these, we're not going to get into the nitty-gritty because I'm obviously not going to take your DNA and test it. And we don't necessarily know where it turns on and off the genes. There are a couple that we do know. Most of them we don't. We don't fully understand it yet. So when it's promoting methylation, it's really just promoting the healthy suppression of those genes. So it's trying to make your body do what it's supposed to do. Now, some of those nutrients that promote methylation are going to be methionine, which is in sesame seeds, Brazil nuts, fish, peppers, and spinach. Folate, which we talked about in our vitamin discussion, leafy greens, sunflower seeds, yeast, liver. A lot of times they'll put folate in enriched products to supplement, or they'll put folic acid, which we talked about that too. That's one of the changes in your genes. Can you use folic acid, or are you stuck with using folate? We talked about that a little bit more in the vitamin discussion, but that might be another good one for your homework, especially if you remember what that is called. And if you don't, it's the MTHFR gene variation. Now, vitamin B6, it's in meats. Vitamin B12 and B6 are both in meats. B6 you can also get from whole grains and some vegetables and nuts. B12 is going to be almost completely in meats or animal products. SAMe is actually almost completely in a dietary supplement. People will take that. It was more popular a couple of years ago. I don't hear as much about people going really gung-ho for it now. It's unstable in food, so it's really not going to do a whole lot from your foods. The dietary supplements are a little bit more stable, but that's going to promote healthy methylation. At one point, they were using that as a preventative for people who were in very heavily polluted areas. Don't think it's being used as much now, but it's still very helpful. Choline is in egg yolks, liver, again, all meat products. Betaine, wheat, spinach, shellfish, beets. It's also in pineapple. Forgot to write that down. Resveratrol in grapes and red wine. Another great reason to take your resveratrol. Eat your grapes. Genisteins and soy, that one's actually one of the cancer preventative ones, especially looking at the soy can act like act more like an estrogen, so it takes over that the area where the estrogen would normally meet. So if there's too much of it, soy can kind of block it out and let it just get excreted. So that can be a very good one for certain types of cancers. And butyrate we talked about a couple weeks ago too. It's in fermented foods. We talked about that when we talked about sleep. And acetylation, like we talked about, activates the gene expression. Broccoli and garlic. They're the sulfur type of foods, really any cruciferous vegetables or any of the allium vegetables. Cruciferous vegetables like broccoli, cauliflower, Brussels sprouts, and the allium vegetables like garlic, onions. Those very, very pungent, extremely smelly ones. Those are going to help activate your genes. Broccoli is one of the very, very few that actually makes a huge difference in the short term. They honestly have no idea why, but even in the very short term, when you're having, when you eat broccoli, it has cancer fighting properties. Most of these are going to take a long time, so you should get a variety of foods to make sure you have something from each group. But broccoli is one of the ones that helps in the very short term. Green tea is another one with cancer fighting properties that work short term. Now, free radical damage. How you avoid free radical damage. So we talked about free radicals are trying to steal electrons from healthy cells and make them problems, make them unhealthy cells and make them more free radicals. Antioxidants have an extra electron that they just give to that free radical, and then the free radical is not trying to take all of the healthy cells electrons anymore. So you know, antioxidants has become a huge buzzword. It is in everything, and that makes it easy because antioxidants are actually in everything. The three that you'll normally see are vitamin A, vitamin C, vitamin E. Selenium is it does help with free radical damage. It's not always classified as an antioxidant, partly because it's a mineral. When we look at antioxidants, we're normally going to talk about vitamins. But you can get those. Getting a whole lot of these foods can really help avoid free radical damage. And like we talked about, free radical damage causes aging. And internal aging, external aging, that's part of the reason why in a lot of these vitamin A, vitamin C, vitamin E, and selenium, you're going to see them in skincare products. People love their antioxidants in skincare products. It's going to help block aging on your skin, in theory. But getting them internally is even better. So you get vitamin A from liver, egg yolks, milk, butter, spinach, carrots, any of those orange vegetables, squashes, broccoli, tomato, cantaloupe, peaches, and grains. Vitamin C, citrus fruits, of course. Bell peppers, cabbage, especially different colors of cabbage, like purple. Spinach, broccoli, kale, and those are preferably, and not necessarily, well, actually, take about all of them. Vitamin C is very heat sensitive, so make sure those are raw to get the most vitamin C. Cantaloupe, kiwi, and strawberries. And vitamin E is normally going to be found with a fat because it's one of the fat-soluble vitamins. So you'll get in nuts, vegetables and fish oils, whole grains, and apricots. Guess there's enough fat in apricots that we have there's plenty of vitamin E in it. And selenium you'll normally get from tuna, oysters. Molasses is actually a really good source of selenium. Mushrooms, herring, cottage cheese, and cabbage. So getting a good variety of these will help combat free radical damage, but really just making sure you're getting plenty of colorful fruits and vegetables. Another fancy word and fancy classification for antioxidants are phytonutrients. Phytonutrients are almost always antioxidants. So get plenty of your fruits and vegetables, and then you have nothing to worry about. Now, I'm going to keep this one fairly short, partly because it's a lot of information. I do want you to come back with questions. And it's a lot to think about. And you may have to watch this one a couple of times because there's a lot to read as part of it too. So we're going to keep this one decently short, but just to go back and for the important stuff, what is epigenetics? I will take an explanation for it, or I'll take the control above your genes type definition, which is kind of what it means. Or epigenetics is your environment's impact onto your genes. Nutrigenomics is just a subset of epigenetics that has to do with nutrition. So it's your food's impact on your genes. What is sickness in the context that we talk about? So you can either use the cup example, or if you can think of another analogy, I love that. So if you can think of another analogy for what sickness is, that'll be great. I use the cup or the funnel example. A funnel is another easy way to do it. If you're sticking a liquid through a funnel and you're trying to put in more liquid than the funnel is letting out, that's going to overflow and you're going to get sick. If you are putting in a steady flow of liquid as it's being let out, then it's just always going to keep cycling through just like it's supposed to. It's not going to overflow. It's not going to become an issue. It's just going to keep funneling through, which is what it's intended to do. So sickness is just that overflow. It's just your body's inability to adapt to its environment anymore. It's at the point at which you suppress your ability, or you, not suppress. There's another S word that I completely blanked on. It goes beyond your ability, your biological ability from your genes to be able to take on your environment. Now, your DNA methylation does what to your genes, while histone acetylation does what to them? Methylation suppresses them. That's the suppress word I was looking for. And then acetylation activates them. And free radical damage causes, you can get into the real nitty gritty of this one, or you can just tell me aging. Free radical damage causes aging. Now for your homework, I do want you to ask questions because again, this is we're gotten to postgraduate level biology on this one. So I don't expect you to fully grab everything and be able to run with it. It's a good thing. It's how you learn. So we covered a whole bunch of stuff that I don't expect you to get all of. I want you to pick something we talked about today that you don't fully understand or you don't know much about and do some additional research. So we didn't talk much about how your DNA works. We didn't talk much about those transcription factors and how exactly they work when it comes to your body and forming your DNA and working on the protein synthesis and things like that. That's a great one to look into. You can also look into more about methylation. You can look into the acetylation. You can look into the other epigenetic tags that we didn't talk about because we really only covered two. We covered the two best researched ones. There are a whole bunch more. But those two are number one, they're the easiest examples because methylation, suppression, acetylation, activation. But they're also best research because they're the easiest ones for us to look at, so far. You can also look into specific illnesses like cancer or the ones on the other page that we looked at, asthma, autoimmune diseases, obesity, and how nutrigenomics affects them and how they can be controlled through nutrigenomics. You may also find that study that I was talking about, or another one, that looked into people's genetic code and created diets for them. That's starting to become a more common thing to do. Again, it is a little hard because we don't know a whole lot about which genes do what, and our body is very, very complex, so they may do multiple things, or two genes may work together to cause one illness, or two genes may cancel each other out. And so because it does become a very complex system, it takes a long time for us to research it. So that is also something you can look into, is what do we know so far? So we covered a lot of things. I want you to look more into nutrigenomics. an incredibly interesting field, at least for some of us. And they're doing a lot of work in it. There's been a lot that's come out in the last 10 or so years on it. I think it's going to become a pivotal part in how we treat medicine and nutrition. So I really do want you guys to look into it and send me the information that you do find. And ask me questions. You guys always feel free to message me and ask questions. I do want to hear them because I expect you to have plenty of questions this week. So let me know. And if you need me to jump on a Facebook chat with you, I also can. That way you can see me talking with my hands on how exactly all this stuff works. So let me know. Other than that, I hope you guys have a great week. And I will see you next week because we only have a couple of weeks left before the final. Thank you, guys.